In Denmark, wind power provides nearly half the country's energy needs. It's a world leader in research and development in the field, and I've come here to visit two of the industry's global giants to see how they're tackling a growing problem presented by the massive blades used in their wind turbines.
Wow, Jonas, these are incredible. They're enormous.
Yes, for sure. 81 meters of wind turbine blade ready to make green electricity.
The problem I'm interested in arises when the turbines stop making green electricity at the end of what's typically a 25-year lifespan. About 85% of a wind turbine's mass can be recycled effectively, but the blades cannot. That's because they're made largely from a composite of epoxy resin and glass, or carbon fiber, that's incredibly difficult to break down, which is why most turbine blades end up like these ones in the United States and landfilled. Now though, we're starting to see a change in philosophy.
Durability and long lifetime was the guiding principles. Right. Now the products have matured, and now we start to integrate, you could say, other requirements, including recyclability.
Last year, Siemens Gamesa launched what it's calling the world's first recyclable offshore wind turbine blade. The key innovation? A new epoxy resin that can be separated easily from the other components that make up the blade. Harold Stecker is showing me the fiberglass mats from a blade tip that's undergone the separation process.
You can see that these glass mats, they are actually of good quality, even the stitching is still intact. So you can collect these glass reinforcements and then use it for automotive industry or for boat building.
The actual process is also more eco-friendly.
The recycling process itself is using acetic acid, so it's like strong vinegar and 80 degrees Celsius. And that's also the strength of this recycling process. So it is not built on nasty chemicals and not very high temperature. And it's easily accessible all around the world.
The German-Spanish manufacturer says the blades do cost more than standard ones, but are not excessively expensive. After years of falling prices, on average globally, wind turbine prices have been rising recently, thanks largely to supply chain problems and increasing freight and material costs. So it may not be the perfect time to be selling recyclability at a premium, but the company has reached agreements to supply the blades to 3 major clients. Before I go, I ask Jonas about the price issue.
Why is any customer going to pay more?
The bill for handling your blade end of life is unknown today, so we will expect legislation around waste handling to increase, and thereby it's also some sort of economic insurance that you buy with the recyclable blade.
Some European countries have already placed bans on putting blades into landfill. It can be assumed more will follow. My next stop is with Danish company Vestas.
Hi, Lisa.
Hi. Hi.
Here, they're tackling the sustainability issue from 2 different angles.
We are working on supporting the development of new recycling technologies. For example, co-processing in cement kilns, but also through pyrolysis technologies. And actually today in the US, we have already recycled 280 blades.
Recycling means the blade's components can be used for other purposes. But the company is also looking to develop a circular solution.
With circularity, we're using the same materials that we used when we produced the first blade and then bring it back into a new blade, thereby creating a circular loop.
So that is essentially zero waste then, the circularity?
That is essentially zero waste. That's the ambition, yes.
It's not an easy goal, and as with Siemens Gamesa, finding a new resin is key. Approximately half the mass of a turbine blade is made up of resin. The bond it creates with other materials has to be extremely strong, which is also what makes it so hard to deconstruct.
We want to design a resin that we can actually use again and again without losing the very important physical and chemical properties that you have. Because such a blade is going to see very harsh conditions.
To advance the development of a new epoxy resin, Vestas has joined CTEC, a coalition of industrial partners and independent Danish scientists.
Nice to meet you.
Welcome. Nice to meet you.
Thank you.
It's a big project, but you have to start small.
So we start our experiments here in the lab with these small test samples, which is exactly the same material that goes into the turbine blade. You can say that the turbine blade is one big molecule, in fact, and we need to find a way to recycle that in order to make wind turbine blades fully circular.
In this small-scale test, filmed across 4 days, the tube on the right of screen shows a new thermoset plastic developed by CTEC, eventually breaking down in acetic acid, demonstrating that deconstructing these new blades can work in theory.
So this is a proof of concept. How can you be certain in 25 years that it'll work?
Well, based on our proof of concept and the science, when I look into it, I can see that it works. We can actually do this. What is next for us and what we're doing in this process is then scaling this into industrial scale. This is why we need the industrial partners, of course, but also in terms of having a process that makes sense in the end, in terms of being something that we can apply industrially.
The coalition will run till 2024 and is aiming to get as close as possible to an industrially viable solution before this date. As for Siemens Gamesa's recyclable blades, while they are now available, of course they won't make any difference until those blades are decommissioned in a quarter century or so. In the meantime, around the world, thousands of wind turbines are now approaching the end of their lifetimes. More than 6,500 blades will be removed each year in Europe until 2025, with about 1,400 removed in the US over the same period. That's a lot of blades, so it may be some time before scenes like this are a thing of the past.